Welcome. Let's look at dividing polynomials. There are two main methods, long division and synthetic division. Synthetic division is for many people easier, but it is very difficult to do if you have a denominator or if you're dividing by a binomial that has a coefficient with the x. Like if this was 7x minus 3, because of that 7, you would actually have to change everything in the numerator. In other words, you'd have to make it x minus 3 over 7, because you can't do it with the coefficient in front of the x. And then everything on the top would have to be divided by 7. So you're going to end up with fractions, which is certainly doable, but it's not necessarily something that is easy to do. So if you have it in that format, you would want to do long division. Well, let's go over the basics of doing long division of polynomials and then doing the same problems with synthetic division so you can see the two methods. And you have to be able to do both methods, so let's work on it. So here we're going to do x minus 2 and the division line and put x cubed minus 9x squared plus 17x minus 1. So the goal here is to find numbers, or to get this, I have to get so that this is x cubed here. So this x has to turn into x cubed so that I can then subtract it and they would both go away. So my goal is to think, what do I do to the x to make it into an x cubed? So the answer to that would be it's an x squared. So I would do x squared times x, and that would give me the x cubed. I'm not going to subtract yet, so I'm going to leave that off. So x squared times x is x cubed. But when you do that, it's like distributing it to both of those things. So I also have to do negative 2 times x squared. At this point, now I will subtract. And that's where x cubed minus x cubed is 0. But for the other one, I have two negatives, so it's actually going to be plus a 2x squared. Negative 9x squared minus a negative 2x squared, or negative 9x squared plus 2x squared, will give me negative 7x squared. And then I'll bring the 17x down. Notice and bring it down. I'm doing that. This is all sort of the same idea as if I did something like, let's do 63 divided by 5. Okay. 5 goes into 63. 5 goes into 6 once. Subtract 5. And then I bring the 3 down as 13. 5 goes into 13 twice, minus 10, 3. And then I could either do a 3 over 5, or I could put a decimal and keep on going, or I could do, I could do a couple of things. In this case, following what we're going to do, I would do 2 plus 3 over 5, or 12 and 3/5. Because that's what we're going to do with this kind of thing. So 5 times 12 is 60, plus 3/5 would give us 63 over 5. This kind of method that you learned originally is what we're essentially doing here. We are finding the thing that makes it so we can subtract from it. The only difference is we need it to be exactly the same. So that means I need a negative 7x squared here. So how do I turn x into that? One of the ways to think about doing it is, if you can't do it in your head, take the two things, take the negative 7x squared, which you want it to be, because that has to be exactly the same as this one, including the negative, and divide it by x. Well, that x cancels with the square part of that, which means just negative 7x is what we need. So I'm going to do minus 7x. Okay, and I'm going to multiply that to both of these things again. So I get the negative 7x here, the negative 7x squared. And then negative 7x times negative 2 is plus 14x. And then just like these others where I was subtracting, I'm now subtracting this. But when I subtract this, so this becomes plus here and that goes away, but then it's 17 minus a positive 14. So it's 17 take away 14, which means it's 3x. 17x take away 14x gives us 3x. And then I'll bring that negative 1 down. And we repeat this. What do I do to the x to make it a 3x? Well, it looks like I'm going to multiply by 3. Keep that in red. So 3 times x is 3x. 3 times negative 2 is negative 6. And now I'll subtract, and I get 0 there, and negative 1, and this is plus 6. So negative 1 plus 6 will give me a 5. I can't make x into 5. So instead, what I now do up here, and I have to erase some of this so that I can put in that 5. That means I'm going to be adding 5 over the original divisor. That's how you do the long division, and that's how you handle a remainder. If there was no remainder, we would just leave it at plus 3 at the end of it. Let's do a second one now. And in this second one, we have it divided by that, but that's the same thing as using a fraction line. They both mean the dividing. So I'm going to set this up to do the same, x plus 5. I think I want to make it a little lower down here. X plus 5, 6x cubed plus 28x squared minus 7x plus 9. So my first job is to make 6x cubed here, and if I'm going to turn x into 6x cubed, that x will cancel with one of those, so it's 6x squared. Now I could put it anywhere on top, but I'm putting it on top of the same x squared ones, just sort of to keep everything in line. I don't need to do that. I could put it over here if I felt like it. Okay. So now I did that times the x, but I also have to do the 6x squared times the 5. Okay, so 6 times 5 is 30, so we get 30x squared. And now at this point, I'm going to subtract. So that becomes 0, but then it's 28 take away 30, so it's negative 2x squared. And then I'll bring down that to make negative 7x. Now I want to change x into negative 2x squared, so that means I need to multiply by negative 2x. Negative 2x times x is negative 2x squared. And then I also have to multiply it to the 5. So I get negative 2x squared here, but then I get negative 10x there. Perfectly fine. We're now going to subtract it. Lots of double negatives. Yay. So that one's going to become a plus. So it's going to be negative 2x plus the 2x squared, which is why this just cancels out. Okay. But then we're going to have a negative here, which is going to be like plus 10x, negative 7x plus 10x, which gives us a positive 3x and then a plus 9. X becomes 3x by multiplying by 3. And then 3 times 5 is the 15. So that's 0, but 9 take away 15 is negative 6. And there isn't anything more to do there, so we do minus 6 over x plus 5. Notice that's minus the fraction. Okay, not plus a negative 6 on top. It's mathematically right, but it's not the normal best way to write a fraction as part of a polynomial. So this is the correct way to write that one. And there's the correct way to write that one. I'm going to make sure I have. Now, good. Now let's do both of these by synthetic division. Here, we just did the same long division type of skills that we learned a long time ago. It seems more complicated doing it with variables, but it can definitely be done using the same concepts. For synthetic division, we're going to get the same answer, but we're going to use a different method. Okay, and that method is I'm going to make a little box here. And that box, I'm going to take this, and essentially I'm making it equal to 0 and finding the x that makes it 0. And that would be a positive 2. Or another way to think of it is take that and use the opposite sign. Opposite sign, which is a positive 2. And then I take the coefficients here. That's 1 and negative 9 and 17. And then at the end, not quite a coefficient. Okay, but still that number. Now a little hint thing here. Okay, well actually first let's continue this. So I have a 1, a negative 9, 17, and negative 1. And I draw a line here, but I leave some space between it. So look at that setup. The setup involves a little half box and then a line with enough space for 2 lines of numbers above it. So the first thing I do is that the first number comes down here. What I'm going to get is a new polynomial, but that's the first one. It just automatically comes down. Then I'm going to multiply. I'm going to do 2 times 1, this 2 that's here times that 1, and that becomes just S plus. So I get this. 2 times 1 is 2. And then I add those together. In this case, it's adding them. -9 plus 2 is a -7. And then I'm going to multiply it again. So what I did is I multiplied to get to that. Now I'm going to multiply to get to that, which is -14. And I'm going to add these together, which gives me a 3. And then multiply those to get a 6 and add those to get a 5. But the last one I go like this for because it becomes the remainder. So what I have here is like this was an x cubed. So this one is called a depressed polynomial. We do the 1 and we do an x squared minus 7x plus 3 plus 5 over the divisor, x minus 2. We don't need the 1 though. We don't usually use 1. And notice that's the same answer as above here, plus 3 and plus 5 at the end. Same answer. Now let's look over doing the next one. As well mentioned, we have a 3, then a 2, then a 1, and then this one's actually the same as x to the 0, but I won't get into that much right now, because that's then the constant. If we didn't have, say, that -7x, we would still actually have to use this. So I'll show you in a moment here. Let's do this as, I'm going to take the opposite sign of that, -5, and then the coefficients. Now, let's pretend that this one wasn't there. If that one wasn't there, we wouldn't have anything there, right? Well, that's true, except that we have to put a placeholder of 0 if there's nothing there. Because of the fact that we're going to be adding and subtracting to that place, we need an actual number there. All right. In this case, though, it's not. In this case, it's the -7. So I'm going to go like that, and then this automatically comes down, and then multiply 6 times 5 is -30, and add them, we get a -2 here. -5 times -2 is a +10, and add them, and we get a 3. And then -5 times 3 is -15. Add them, and we get -6. So this becomes a depressed polynomial because it was a 3. And then now that means we'll put x squared with that one. So the 3 goes down to a 2. That means this new polynomial is 1 less. So I guess you could say that's why it's depressed. It lost something. Bad math pun there. Oh, bad math joke. But I am going to put an x squared and then an x and no x with the 3. So let's actually write that out. 6x squared minus 2x plus 3 minus 6 over that original fraction, x plus 5. That's how you account for the remainder in these. Oops. Don't go away. Data go away. Okay, might get it through this time. All right. Now notice then that's the same answer as this one above here, the -2, the 3, the -6 over x plus 5. Okay. So synthetic division and long division could be used interchangeably, except that, like I said, this kind of a setup would make it more difficult for synthetic division, a lot more difficult. And that's how you do long division and synthetic division. Thank you for watching and listening today.